So today we're going to be talking about Chapter 2, in particular Chapter 2.1, which will be discussing qualitative data. But in Chapter 2, our major objective is to learn how to organize and present data that has labels. So in Chapter 2.1, we will put variable data into tables by category and frequency. We will graph the label data into bar graphs and pie charts, and we'll calculate relative frequency or percentages by category. Finally, we'll interpret graphs. In this chapter, we are going to look at two types of variables. One is qualitative and the other is quantitative. Some books present qualitative data as categorical. We will stay with qualitative for this particular text that we're working with. So, for example, the labels that we may be interested in for qualitative variables may be gender or eye color. They have certain labels associated with them. And the graphs that we're going to be looking at for qualitative data is going to be bar charts or pie charts, and we will create relative frequency tables or frequency tables prior to setting up the charts. For quantitative variables in this chapter, we're going to look at continuous or discrete type of variables. Continuous variables might be temperature or pressure, height, weight. Discrete variables may include age, which has usually only an integer number associated with it. But the graphs that we're going to look at for quantitative variable are histograms and dot plots. And when we get to Chapter 2.2, we'll discuss those in detail. And again, we will look at frequency tables and stem and leaf plots when we get to that chapter. So the first idea is we will create a table before creating the graph. That is a very important idea in this chapter, and we are going to do that first. Then from the frequency table counts and the numbers of observations by category or class interval, that will be creating our table. And then from the table, we will graph based on a two-axis format, a X horizontal and a Y vertical. The X-axis is going to contain the variable of interest values. And for qualitative variables, it will be a category. Finally, our y-axis will contain frequency or relative frequency. And we will show you those in just a second. So for qualitative variables, the following bar chart or bar graph, I'll put it as bar graph, shows the frequency of shark attacks by state or country. So as you can see, our categories are either state or country, right? And that is our x-axis. And our frequency axis, which is the y, shows the number of shark attacks, right? In this example, it shows that Florida has over 350 shark attacks per year, whereas Hawaii, California, Australia, Brazil, South Africa, and New Zealand are less than 100 per year. So our most interpreting this particular bar graph, we see the most frequent number of attacks per year of sharks is Florida. Don't go to Florida. So before we get to actually creating the bar graph, we want to organize our qualitative data into tables. To do that, we create what's called a frequency table. Here it is. So in the first column, we have the categories of interest of our variable. Okay, and then in the second column, right, which is this column here, is our frequency, which counts the number of individuals for each of the categories. In this particular example, we're looking at 150 patients that have been surveyed for blood type. For example, in this particular table, the A blood type has 60 individuals that had type A blood. Type B blood was 20 individuals. Type O was 65, and AB was 5, right? So now, from our frequency table, we can create a picture using a graph, an X and Y axis. So you will notice that our categories will show up in the X-axis. We have, for example, A, B, O, and AB on the X-axis. And then our frequencies are shown on the Y-axis there. From this particular graph, we can see that the O blood type is the most frequent at 65, and the least frequent appears to be AB blood type. We are often asked for, instead of frequency within a sample, we are sometimes asked for the percentage of individuals within a sample having a particular characteristic. When we're asked that question, we go to something called relative frequency. Relative frequency is the ratio or percent of individuals that have a characteristic based on a variable. So, for example, in our calculations of the previous table, which included blood type and the frequency, we now can create another column called relative frequency. And in that particular case, it is just the category count divided by the total count. So, for example, for type A blood, if we take the count of 60 and we divide it by 150, we get a relative frequency of 0.4. Now, if we multiply that by 100%, we get 40%. Once we've created the relative frequency table, we can create a relative frequency bar chart, which we will show you down here at the bottom. And again, on the x-axis, we put in our categories A, B, O, and AB. And on the y-axis, it's our relative frequency. They go from 0 to 0.5 in this case, because that's the maximum that we need to have to include all of our relative frequencies. In this case, you can again see that O has the largest number of individuals that have the blood type O in this sample. 43% of the individuals have O type, 40% have A type, and the least number of individuals with blood type AB is 3%. Well, doing the statistics does not mean much of anything unless we're able to interpret the charts and the graphs, as well as the tables to go along with that. So to interpret bar charts, we look at the features of the categories relative to each other, and that's just looking at the bars relative to each other. And for example, in the blood type sample, the bar chart shows that the O type is the most common blood type and is about 43% of the sample that has type O blood. The least common blood type in this sample is AB. As a medical health provider, this information is important in knowing the population of blood types so that you know what you have to have on hand in order to do transfusions. Well, I would like you to look at problem number 32 on page 48 in the text. We will be discussing that in the classroom. The other thing is we have not discussed pie charts, and I would like to do pie charts using the computer. And so in our computer labs, we will show you how to create pie charts because it's a little bit more complicated. Typically, you can eyeball it, but if you want to be real accurate, you would need to use a protractor, and we won't require that in this particular class. So that's the conclusion of Chapter 2.1. We will start Chapter 2.2 in the next group of slides. Thank you.